In this presentation, we have to present the Dirac's equation in the covariant form. Say covariant form of Dirac's equation. Further, consider Dirac Hamiltonian H equal to C alpha dot P plus beta MC square is E equal to H. This is the Dirac Hamiltonian for a free particle. Then instead of E, we have to use our operator IH cross dou by dou T. It is energy operator. Instead of P, we have to use our momentum operator IH cross delta. Then the equation 1 is modified as IH cross dou by dou T equal to minus IH cross C alpha dot del plus beta MC square. Now allow these operators to operate on the wave function. We can get IH cross dou psi by dou T is equal to minus IH cross C alpha dot del psi plus beta MC square into psi. Say this is equation number 2. Now multiply equation 2 by beta by H cross C. Here I beta by C dou psi by dou T. H cross cancelled out, so I beta divided by C dou psi by dou T is the remaining term. Here H cross C is cancelled out, so minus I beta alpha dot del psi plus beta square MC divided by H cross, because MC square is present here. This should be divided by this term should be multiplied by beta, so beta into beta square. MC square by H cross is MC by H cross. We know that beta square is equal to 1 from our Dirac matrices. So the above equation is modified as I beta divided by C dou psi by dou T, which is equal to minus I beta alpha dot del psi plus MC by H cross into psi. Here also you have to multiply by the wave function psi. Now bring all the terms to the left hand side. I beta by C dou psi by dou T plus I beta alpha dot del psi minus MC by H cross into psi equal to 0. Say this is equation number 3. Here take this one as a first term I beta. Here it is a vector alpha, so this is alpha is written as I into alpha x plus j into alpha y plus k into alpha z. This is the value of alpha. Then this is del operator, the value is I into dou by dou x plus j into dou by dou y plus k into dou by dou z. The entire is multiplied by psi and minus MC by H cross into psi equal to 0. See here I have written this term as a first term. I beta is taken away, then alpha dot del is alpha is a vector I into alpha x plus j into alpha y plus k into alpha z. These are all the Dirac matrices. Dot, then del operator value is I into dou by dou x plus j into dou by dou y plus k into dou by dou z into psi. Then I have written this term minus mc by h cross into psi equal to 0. Then this term should also be present, plus I beta by c dou psi by dou t. This is the third term. So in total 3 terms are present. And this is modified as I beta I dot I 1. So this is alpha x dou by dou x plus j dot j 1. So alpha y dou by dou y plus k dot k 1 alpha ez dou by dou z. Entire is multiplied by psi. Then plus I beta by c dou psi by dou t minus mc by h cross into psi equal to 0. This is equation number 4. Say in this equation you may write I beta summation over k equal to 1 to 3 alpha k dou by dou xk. Instead of these 3 terms we have to write like that, which means that if we put k equal to 1 we can get alpha 1 dou by dou x1 plus alpha 2 dou by dou x2 plus alpha 3 dou by dou x3. Instead of x, y, z we have to introduce 1, 2, 3. So these 3 terms are written in this form: I beta into summation over k equal to 1 to 3 alpha k dou by dou xk. If you put k equal to 1 alpha 1 dou by dou x1, the next term plus alpha 2 dou by dou x2 plus alpha 3 dou by dou x3. So this should be multiplied by psi, this side. Then this term is written as such: plus I beta divided by c dou psi by dou t minus mc by h cross into psi equal to 0. Then this equation is further modified as I beta summation over k equal to 1 to 3 alpha k dou psi by dou xk minus beta by ic dou psi by dou t minus mc by h cross into psi equal to 0. Here I have multiplied the numerator of this term by I and divide the term by I. Multiply the numerator by I as well as the denominator by I. Therefore I square minus 1, this minus sign. So minus beta divided by I into c. Now introduce a matrix gamma k that is equal to minus I beta alpha k, where k equal to 1, 2, 3, and another one matrix gamma 4 is equal to beta. Just I have introduced 2 matrices. One is gamma suffix k. The value of gamma suffix k is minus I beta alpha k, where the value of k equal to 1, 2, 3. Then I have introduced another matrix gamma 4. Then the value of gamma 4 is equal to beta. Now this is equation 5. Now the equation 5 is modified as, see here, I beta alpha k is minus gamma k. Instead of I beta alpha suffix k, we can write minus gamma suffix k. Say this one is modified as summation over k equal to 1 to 3 minus gamma k dou psi divided by dou xk. Here beta is our gamma suffix 4. So gamma suffix 4 divided by IC into dou psi by dou t then minus mc by h cross into psi equal to 0. So this is equation number 6. Now the above equation is modified as gamma k, here summation over k equal to 1 to 3. All the terms are converted into positive. Gamma k dou psi by dou xk plus gamma power 4 divided by ic dou psi by dou t plus mc by h cross into psi equal to 0. This is equation number 7. Just I have multiplied all the terms with the help of a negative sign. Here 0 into minus 0. So all the terms are expressed in terms of a positive quantity. Now let us introduce a quantity x mu. This is 4 vector. With the components mu equal to 1, 2, 3, 4. x1, x2, x3, and the value of x4 is equal to ICT. This is called 4 vector. Just I am introducing a new component x mu. If you write mu equal to 1, 2, 3 and 4, then we can get the values x1, x2, x3, and the value of x4 is equal to ICT. This is called as 4 vector. With the help of this, now we have to modify these two terms. See here, summation over, so this is gamma suffix mu and dou psi divided by dou x mu plus mc by h cross into psi equal to 0. So this equation 7 is modified in this form, because to check this one, put mu equal to 1. We may get gamma 1 dou psi by dou x1. Then here mu equal to 1 to 4. If you put mu equal to 1, you can get this first term. Up to 1 to 3, these are all the terms. Say this is modified as gamma 1 dou psi by dou x1 plus gamma 2 dou psi by dou x2 plus gamma 3 dou psi by dou x3 plus gamma 4 dou psi by dou x4. This is the meaning for this process. Plus mc divided by h cross into psi equal to 0. See here gamma suffix k dou psi by dou xk is present. The meaning of gamma k dou psi by dou xk is gamma 1 dou psi by dou x1 plus gamma 2 dou psi by dou x2 plus gamma 3 dou psi by dou x3. So these three terms are nothing but our gamma suffix k dou psi by dou xk. Then what about this term? Say gamma power 4 is available here, gamma power 4. Then dou psi by dou t, IC into dou t is present here. Dou psi by dou x4. What is the value of x4? x4 is equal to ICT. So take the IC outside, because C is a constant, I is also a constant. So I into C. T is a variable. So instead of x4, we may put ICT. So IC into T, we can get this term. So these two terms are modified in terms of this single term. Then the remaining term is plus mc divided by h cross into psi equal to 0. So this is our equation 8 is our Kj equation, Dirac equation in the covariant form. Further we may modify this. Gamma mu dou mu plus mc divided by h cross into psi equal to 0. This is the covariant form of Dirac's equation, because the quantity dou by dou x mu is written as, so entire should be multiplied by psi. See, this quantity dou by dou x mu is written as dou mu. This is one simple representation available in tensors. So instead of dou by dou x mu, we have to write dou mu. So gamma mu dou mu plus mc by h cross into psi equal to 0. This is called a covariant form of Dirac's equation.